In this video, we'll be going over suspension bridges and taking a look at integrative analysis, as well as all the parts and components of a suspension bridge. So our objectives here are to be able to identify the parts of a suspension bridge, and also to be able to analyze the loads and forces on that suspension bridge with integrative analysis.
Okay, so for some quick review, here is a suspension bridge. Now first, at the base, we have our foundation, then we have our piers and anchorages, which hold the main cable down. Then we have our towers, our main cable, and suspenders, which attach the main cable to our deck. Now what undergoes tension in a suspension bridge would be our cables and suspenders, as they need to maintain tension in order to hold up the deck, as well as our anchorages that need to remain in tension to maintain the main cable. And for compression, both our towers and foundations need to resist the tension forces from the cables and suspenders.
So now that we've reviewed those concepts, we can take a quick look at some questions. So we're trying to find out if the main cable and suspenders undergo tension, and if the anchorages undergo tension, if the towers and foundations undergo compression, and how the angle between the main cable and the horizontal affects the tension force in the cable. And then finally, we'll take a look at some integrative analysis with this example, looking for the tension in the main cable. So now, take a few minutes to try these questions on your own, then come back to this video. Okay, so now, looking at the first question here, we're looking to see if the main cable and suspenders undergo tension. Now, recall our drawing from earlier. This is true. As we've labeled it here, the cables and suspenders are being pulled and undergo tension in order to hold up the deck. Now, is that also true for the anchorages? From what we labeled, yes it is. They are also pulling in tension, trying to maintain the main cable. So this is also true. And now we're looking at compression. So do the towers and foundation undergo compression? And the answer is also yes. They are withstanding the tension forces from the cables and anchorages to maintain equilibrium. So these are also true. Now we need to look at the angle between the main cable and the horizontal, the larger the tension force. So this is false. So the tension force and the angle are inversely related. So that means as the angle gets smaller, the tension force gets larger. And the way you can think about this is you can think about it in terms of trigonometry. So the x and y components are found by multiplying the tension force by either sine or cosine of that angle. When the angle is smaller, the tension force has to be bigger to compensate for that, to maintain equilibrium throughout the entire thing. Okay, and now the last question. So we're given a few values here, and we're looking for the tension in the main cable given this angle from the horizontal. And we'll be looking right here on our suspension bridge. So this is the first center point. We're going to start by analyzing one point. And we have a tension force, TO, and we have F1 in this case, which has just been labeled arbitrarily, which is our 5 meganewtons. And this will be true for all suspenders. So all of the suspenders going down, which I've shown in green here, will be 5 meganewtons. And then we have our tension 1 force, which will go up to the next suspender point, and we have that angle of 0.08 radians. And then we have our y and x components. So to find this tension force, we're first going to start by taking our equilibrium in the y direction. So 0 is equal to the absolute value of F1, and that's negative because it's going downwards, plus T1 times sine 0.08, and that is our y component, T1y. So T1 is equal to 62.5667. And that is because we know F1 is 5, so when you rearrange it, move it to the other side, then divide by sine 0.08, this is what you get. So if we round that up, we get that T1 is equal to 62.57 meganewtons, making this the correct answer. So, in summary, here are the questions and their answers. Thank you for watching this video.